How do you turn 8 square miles of volcanic rock into a meat grinder? The Japanese army had exactly 1 year to find the answer. They didn't build a defense, they carved a tomb. General Tadamichi Kuribayashi arrived with a grim mathematical certainty. He knew his 21,000 soldiers were already dead. There would be no evacuation, no resupply, no hope. He abolished the traditional banzai charge, viewing it as a waste of imperial lives. Kuribayashi wanted a war of attrition so bloody it would break the American will to invade Japan. The geography was his greatest weapon. Imagine 11 miles of tunnels snaking through the dark. That is the distance from Lower Manhattan to JFK Airport, all hand-dug into the sulfurous earth. The process was primitive but relentless. A soldier swung a pickaxe into the soft volcanic stone. The rock crumbled easily. He dug deeper, venting the heat of the volcano through narrow shafts. By the end of the year, the island was hollow. They had created 5,000 caves and underground chambers. Above them, 1,500 concrete pillboxes grew out of the black sand like jagged teeth. Sand was the first problem for the Americans. It was soft, volcanic, and gray. You couldn't stack it into sandbags. You couldn't dig a foxhole without the walls collapsing. The Japanese stayed below the surface, invisible and waiting. Kuribayashi's logic was simple. Every soldier received a final mechanical directive. Do not die until you have killed 10 enemies. While General Kuribayashi finalized his death pacts, the United States Navy was committing a fatal error. They saw a target. They saw an island. They did not see a fortress. For 74 consecutive days, the horizon burned. Warships and bombers unleashed 6,800 tons of explosives. This was the weight of the Eiffel Tower, rendered in steel and TNT, dropped onto 8 square miles of rock. 22,000 shells followed. It was the longest sustained aerial and naval bombardment of the Pacific War. American intelligence looked at the craters and saw victory. They estimated 4,000 defenders. They were wrong by 17,000. The planners assumed the island had been hammered into submission. They cut the final bombardment short. But the math of destruction failed. Out of 1,500 Japanese fortifications, 1,300 remained untouched. The shells hit the surface. The Japanese were 3 stories below it. The Marines hit the beaches on February 19, 1945. It began with an eerie, rhythmic silence. Then the volcanic sand exploded. By nightfall, the Americans had crawled forward less than 700 yards. The price for that dirt was 2,400 casualties. In the dark holds of the landing ships, 8 specialized machines waited. These were the new Zippo Shermans. They were too precious to risk in the first wave. They were irreplaceable. The tanks waited for dawn. The 5th wave of Marines hit the black sand of Iwo Jima. Among the Shermans rolling off the ramps, 8 tanks looked identical to the rest. They weren't. These 8 machines would soon account for 1/3 of all Japanese casualties. To break the deadlock of the Pacific, the Americans had to resurrect a nightmare from the Middle Ages. Why did the civilized world abandon flamethrowers only to bring them back in 1945? The answer lies in the history of terror. Fire has always been the weapon of last resort. The Byzantines perfected it first with Greek fire. Imagine the sound, a low predatory hiss echoing across the water. It was a pressurized liquid flame that turned enemy ships into funeral pyres. Water couldn't extinguish it. The formula remains a mystery to this day. Fire evolved. It became more chaotic. In some medieval sieges, soldiers set pigs and other animals on fire, driving them toward enemy lines to spread panic. But the modern horror began in 1914. The German Empire introduced the Flammenwerfer to break the stalemate of the trenches. When the first jet of liquid fire arched across no man's land, the effect was psychological. Allied soldiers froze. The roar of the ignition was more terrifying than the heat itself. The weapon was a double-edged sword. It was notoriously unstable. A sudden shift in wind could turn the operator into a human torch. In several documented cases, entire German squads were incinerated by their own equipment. Engineers tried mounting these units on tanks as early as World War I. The experiments failed. By 1918, the world was horrified by what it had seen. Most nations scrapped their flamethrower programs and removed them from their military manuals. American planners ignored the flamethrower after 1918. On the eve of the Second World War, the Allies held no dedicated flame units, no specialized training, no doctrine. The weapon was a ghost of the Great War, tucked away in dusty manuals. Then came the reports from Europe. German assault teams were using flamethrowers to shatter defenses in Poland and France. The Wehrmacht proved that fire still dictated the pace of the breakthrough. American engineers returned to their drawing boards. They rushed new handheld designs into production long before the first flame tanks existed. These portable units were a walking contradiction. A soldier carried a tank of fuel on his back, becoming a mobile bomb. One bullet meant a localized inferno. Could a rifle stop a concrete bunker? No. Could a grenade? Often, the blast wasn't enough. On Iwo Jima, the Japanese built their fortifications with zigzagging entrance tunnels. Shrapnel couldn't turn corners. Fire could. Clearing a single pillbox required the operator to crawl within 30 yards of a machine gun. Iwo Jima had 1,500 such positions. The handheld flamethrower was a desperate half-measure against an island made of stone. It was the only way to reach the enemies hiding behind the 90-degree turns of the deep Japanese bunkers. 5 gallons of liquid death sloshed in a backpack behind the soldier's spine. The American military engineered the M1 flamethrower for one purpose: to reach where bullets could not. It was a heavy, primitive machine. 2 main tanks held the fuel. A third, smaller cylinder sat between them, packed with compressed nitrogen to propel the jet. The weapon weighed 70 pounds when full. A soldier carried the weight of a small child while sprinting through machine gun fire. He had exactly 7 to 10 seconds of firing time. After that, he was an unarmed target. How far could the flame reach? 40 yards. That was the limit. In most cases, the operator had to crawl within 20 yards of a Japanese pillbox to be effective. Early models used electric battery ignition. It failed in the humidity of the Pacific. Engineers replaced it with pyrotechnic flares. White phosphorus ignited the stream. The mixture was a precise chemical cocktail of diesel, gasoline, and napalm compound. It wasn't just fire. It was a sticky, gelatinous mass. Before the trigger was pulled, the air smelled of heavy industrial fuel and raw chemicals. The heat reached 1,500 degrees Fahrenheit. This is the melting point of brass. The gel clung to concrete. It surged through narrow firing slits and wrapped around corners. Operators perfected the cold start tactic. First, they doused the bunker in unlit fuel. They watched the mixture drip into the deep cracks of the fortification, soaking the interior. Then, they fired a single ignited burst. The entire bunker turned into a furnace. The flash of the bunker's destruction was a death sentence for the man who caused it. Napalm worked. The delivery system did not. An M1 flamethrower weighed 70 pounds. Imagine running into a wall of lead with a teenager strapped to your back. You had to get within 40 yards to be effective. Hand grenade range. How many chances do you have to survive with a napalm tank on your spine? Almost none. On Iwo Jima, 94% of flamethrower operators were killed. The weapon was a magnet for every Japanese barrel on the island. The backpack was unmistakable. The stream of fire was a flare. Once the fuel ran out, the operator still carried 45 pounds of empty steel. He had to crawl back through a front line that had just watched him incinerate their comrades. The first massive deployment in the Solomon Islands proved the concept was suicidal. The Army needed armor. They needed the Satan. Engineers butchered the M3 Stuart light tank to create it. They shoved a modified handheld system into the hole. It doubled the range. It provided 40 seconds of continuous fire. But the Satan was a mechanical nightmare. It suffered a 40% failure rate in combat. The internal tanks jammed the turret traverse. Worse, the Stuart's thin skin crumpled under anything heavier than a machine gun. It was a volatile, unreliable bridge between two eras. The brass saw the potential, but they hated the cost. The military demanded a platform that didn't break down or burn its crew alive. The army decided to build a true heavy carrier. 5 months before the invasion of Iwo Jima, engineers received the order to take the M4A3 Sherman chassis and do the impossible. The previous failures of the Satan tanks and the high mortality rate of infantry operators demanded a heavy, reliable carrier. The army needed a fortress that breathed fire. How do you hide 300 gallons of napalm inside a cramped tank? The solution required 1,200 man-hours of labor per unit. Inside the hull, the transformation was total. Mechanics stripped the interior to the steel. They laid over 1,000 electrical connections. They welded 300-gallon fuel reservoirs directly into the frame, consuming 150 pounds of welding rod per machine. A specialized projector replaced the 75mm main gun. From the outside, the silhouette remained unchanged. It looked like a standard Sherman. This was the trap. The Dragon could throw a stream of fire across 150 yards. The turret rotated 270 degrees, tracking targets with the same precision as a tank shell. Once the valve opened, the crew had 80 seconds of continuous flame. The machine was a high-maintenance beast. The napalm mixture had to be used within 72 hours, or it would clog the internal plumbing. Refueling the massive internal tanks took 2 hours of precision pumping. Each conversion cost the equivalent of $350,000 in today's currency. By the time the fleet sailed for the Volcano Islands, the Army had finished exactly 8. On the morning of February 20th, tank number 431 finally opened its fuel valves. It moved toward the Motoyama airfield. Marine infantry remained pinned down by heavy fire from a reinforced pillbox. The Dragon didn't stop. How much fire can one machine produce? A 15-second burst from a single Sherman equaled the output of 2 full platoons of infantry flamethrowers. It wasn't just a weapon, it was a localized sun. At 100 yards, the tank unleashed a stream of thickened napalm. A Japanese 47mm anti-tank gun scored a direct hit on the Sherman's hull. The shell bounced off. The jet of flame didn't flicker. It engulfed the position until the concrete glowed. The Marines moved forward. Within 6 hours, all 8 flame tanks were in the line. They moved from one bunker to the next, methodical, relentless. Standard Shermans followed 50 yards behind, providing cover, while infantry mopped up the charred remains. Heavy naval guns had failed to crack these fortifications. The Dragons dissolved them in seconds. The psychological snap was instant. Japanese defenders watched the liquid fire curve into their embrasures. They didn't wait for the heat. Soldiers abandoned their underground posts in total panic. When the flame hit the embrasure, the most terrifying process happened deep inside. Conventional weapons required a direct hit. A grenade fragment had to find flesh. A bullet needed a line of sight. Japanese engineers knew this. They built their pillboxes with zigzag corridors, grenade sumps, and reinforced channels. A defender could simply kick a grenade into a pit seconds before it detonated. The fortification was designed to swallow explosions. The flamethrower didn't care about geometry. One burst from the Zippo tank lasted 15 seconds. The napalm didn't just fly, it flowed. It stuck to the concrete ceilings and dripped into the lower levels. The temperature inside spiked to 800 degrees. This was the mechanism of the vacuum effect. The fire consumed every molecule of oxygen in the confined space within seconds. The air vanished. Those deep in the tunnels died without a single burn on their skin. They collapsed while clutching their throats, their lungs searching for air that had turned into carbon monoxide. Medical reports later described bodies with no external trauma, only the purple tint of acute asphyxiation. Was it a humane death? Some military theorists argued the heat overwhelmed the nervous system too fast for pain to register. The crews on the ground knew better. They heard the sounds coming from the ventilation shafts. The screams from the caves carried over the roar of the Sherman's Continental engine. Japanese defenders soon realized 47mm anti-tank guns were useless against the Sherman's frontal armor. They changed tactics. Survival gave way to a calculated, suicidal escalation. Flame tanks moved into range. The napalm didn't just burn, it flowed. The thick mixture seeped into every ventilation shaft and cave entrance, turning the underground network into a pressurized furnace. Inside, the physics of death were simple. The fire consumed all oxygen. Then it found the stockpiles. Tons of Japanese ammunition and fuel sat in those tunnels. When the flames reached the crates, secondary explosions transformed the mountain into a series of erupting volcanoes. The shockwaves killed those the fire missed. The cave-ins buried the rest alive. Could anyone escape? Marines sealed the exits with demolition charges. They stood by the rocks and listened to the muffled pops of grenades and pistol shots from deep underground. The defenders were choosing their own end. Even the heights offered no refuge. Tank crews drove onto uneven debris to tilt their holes upward. They bypassed the elevation limits of their projectors to spray fire onto the very tops of the cliffs. Japanese soldiers chose the fall over the flame. They jumped from the precipice to avoid being burned alive. By March 11th, the Japanese responded with a tactic as visceral as the napalm itself. They became human bombs. Soldiers strapped explosives to their chests and sprinted toward the steel holes. Most died in the dirt under a hail of machine gun fire. Some didn't. On that Tuesday, a lone soldier reached flame tank number 438. He threw himself onto the rear engine compartment and detonated. 3 American crewmen died instantly. General Kuribayashi sent a final, grim radio transmission to Tokyo, stating that his troops were powerless against the scorched earth machines. The 47mm anti-tank guns failed. To stop the steel incinerators, Japanese soldiers turned themselves into human mines. They lunged at the Shermans with satchel charges. One suicide diver reached the engine compartment of tank number 438. A massive explosion followed. 3 American crewmen died instantly. General Kuribayashi sent a final, grim radio transmission to Tokyo. He stated that the enemy's special flame tanks caused more damage than all artillery and aerial bombardments combined. The Japanese had no counter. The defense was melting. To maintain this inferno, American crews worked without sleep for days. 8 tanks changed the math of the entire invasion. How effective were they? Military analysts later estimated that the flame tanks reduced Marine casualties by 40%. Thousands of men lived because these 8 machines existed. The pace was relentless. Engineers worked around the clock in improvised repair pits. While the front line smoked, crews refilled tanks with thickened napalm and drove straight back into the kill zone. They operated on a cycle of fire, fuel, and exhaustion. By mid-March, the pressure became unbearable. The coordinated Japanese defense shattered into isolated pockets. Organized resistance collapsed. March 21st marked the beginning of the end. Every operational tank moved to the starting line. 6 battered veterans from the original unit stood alongside 4 new machines fresh from Hawaii. The engines roared. 10 Shermans formed a steel wall. This was the largest concentrated flamethrower assault of the Pacific War. A line of tanks surged forward. No single bunker was the target. They burned the entire horizon. Jets of napalm arched over the black sand. Thick orange fire hit the Japanese positions. Then came the explosions. Regular Shermans followed the flame, collapsing what the heat had already hollowed out. How much fuel does it take to erase an army? In one day, the tanks incinerated 8,000 gallons of mixture. That is the volume of a standard railway tank car. By nightfall, the earth was a scorched black void. 92 Marines died in the final push. 257 were wounded. For Iwo Jima, these numbers were a miracle. A conventional infantry assault would have tripled the body count. The tanks paid the price for the speed. 2 flame Shermans were blown apart. The rest were mechanical wrecks. Engineers stripped the dead tanks for parts to keep the living ones moving. They cannibalized gears and hoses in the mud. The final pocket of organized resistance evaporated. 360,000 gallons of fuel had been spent on this rock, enough to fill an Olympic swimming pool halfway. The smoke over Iwo Jima finally cleared. Out of 21,000 Japanese defenders, only 200 emerged from the tunnels to surrender. The rest remained underground. Most were buried forever in the very labyrinths they had dug. The cost of the breakthrough was liquid. Portable and tank-mounted units incinerated 360,000 gallons of fuel mixture on that single rock. It was a strategy of total erasure. Marine commanders were unanimous. Without the flame tanks, the island would not have fallen. The already staggering casualty lists would have doubled. The Pentagon saw the results and doubled down. They stripped damaged tanks for parts to keep the survivors running. Engineering teams shipped the hulls back to Hawaii for refinement. This evolution didn't stop in 1945. The lessons of Iwo Jima's tunnels eventually birthed the M67 Zippo, a weapon that would define the tree lines of Vietnam decades later. But the immediate target was closer. Production went full steam ahead. Factories converted 70 more Shermans into flame-spewing variants. The military prepared them for the planned invasion of the Japanese mainland. They didn't have to wait long. On Okinawa, these machines consumed another 200,000 gallons of napalm against the final Japanese defenses. The flame tanks were already fueling up for the next objective.